Hello, hello, hello. Welcome to this week's webinar. I'm Jeffrey Palermo, the Chief Architect of ClearMeasure. We are a software architecture company that empowers our clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. And today we're talking about database deployments with Octopus Deploy and Azure pipelines. And the two tools, they really integrate well together for a completely automated DevOps environment. There's lots of documentation showing how to deploy applications in this environment, but often the examples don't include complex SQL Server databases. So that's what we're going to talk about here today. And there is a Q&A window in the webinar. I'm pretty good about answering questions throughout the webinar. So I ask a question there and I'll just kind of work it in as natural. Also, we're going to be using the chat window to funnel in some features, and so you want to pay attention to that. And the first chat just came through. So I know probably lots of development teams are working remotely, more and more so today, and so there's two things that I kind of wanted to offer some promotions that we have. First is a free offer for a 30-point DevOps inspection for your Octopus Deploy pipeline in your environment. If you've implemented Octopus Deploy, it's always good to have a second pair of eyes. Just look at all the different pieces and see what you missed or what the gaps are. We have a 30-point rigorous inspection across 7 different areas of the pipeline, and every one of the any findings that we have, any gaps that we see, suggestions come with concrete recommendations and a written report, and then an interactive briefing of that report. So just let us know. You can something as simple as putting something in the chat, clicking on the link that was provided, or just sending me an email to request the free 30-point Octopus Deploy pipeline inspection. Also, something that I'm doing a lot of, just because here we have the time with more people working from home. There's a lot of development teams that are set up for in-person, in-office working environments, and working from home is really just turning things upside down. And so if you'd like just a um, a simple video call with me to talk about how to get your team moving fast, delivering quality while your team is working remotely, distributed team, I would be more than happy to help you out with that. Absolutely no strings attached, no fee, no commitment whatsoever. Just send me an email and ask for it. Just we'll get on my calendar, and I would be happy to share all the ins and outs of working with a distributed team. And you can get high performance, high productivity, high throughput. You can maintain the team quality, and there's certain methods that really help managers see what's going on and what items are starting to become a bottleneck. And that's very different when each individual person is not physically in the same room. So I'd be happy to help out in that regard, because I know a lot of things are changing these days. Uh, so before we go on, we are talking more specifically around database deployments and how those need to interact with an Octopus Deploy based pipeline. ClearMeasure is a United States Octopus Deploy partner. Octopus Deploy being an Australian company. We're probably the most active Octopus Deploy implementer in the U.S. And we've done some joint webinars. You can look at our catalog and our YouTube channel with Paul Stovall, the CEO of Octopus Deploy. We do a lot of work with them. Now, our goal here is to have high speed, high quality database changes. We don't want to be fearful of changing the database. And we know that some different application components can be really resilient and pretty darn simple, but the database, man, if there's anything that goes wrong with the database, the system is hosed. So it's really, really important. But at the same time, we don't want it to hold us back. And so that's the challenge that we're facing today. Now, um, as an architect, you're responsible for the fitness of the software. You're accountable for the stability of that entire system. and you're the one that must equip your development teams with the overall process for developing the software and deploying it, and that includes a SQL Server database. And so some of the symptoms that we see when going into clients and looking at their development teams and their processes to help them move faster and increase quality, one of the things that holds people back is manual database deployments. And even though some of the application components may be automated at this point, at least from a build and maybe basic deployment standpoint, even if the testing is not yet on board, or static code analysis or formal inspections, the database deployment is a lot of times left out. And there's a kind of a joke, a meme that's gone around the internet when it comes to this. It says um, number of DevOps demos that do not include a database, 100%. Number of real world applications that do not have a database, 0%. And so every application has a database. So it needs to be part of the database pipeline. And architecturally, in order for an application to be autonomous, it needs to own its transactional data. In a world where a lot of people are building more microservices and they're decomposing their larger software systems into smaller autonomous services, those services need to own the data upon which they do transactions. They're going to get, of course, we're going to get data in from other parts, and we're going to get copies of data that we operate on, but the kernel of data that belongs to me as a service, whether it be an app that has screens or a service that's just headless that kind of runs under the covers, if something is going to be an autonomous, deployable unit of software, that unit that's most likely called an application of some sort, a visual, encapsulated in a Visual Studio solution, it has to own the data upon which it executes transactions. If it doesn't, then it's not autonomous, and it's definitely not a microservice if it's not autonomous. And maybe it's an independently deployed component that has a connection string with the database. Then it's just one piece of a distributed application. It in and of itself is not a service because it's not autonomous. That's just an architectural aside. Now, a lot of times an incomplete development environment or lack of software configuration management being applied to the database, that can be the problem for why it's not included. But you can have some architectural hurdles if you have a lot of different pieces of deployed software that all have the connection string to one big database. That happens a lot of times with legacy systems, but there is a solution, a DevOps solution for that as well. And that is, and I'll talk about this later, and that is to recognize that the database itself, these old legacy, big, hairy databases, maybe they're a software system in and of themselves. And if that's the case architecturally, then they need to be equipped with their own independent DevOps pipeline. And then they need to share or publish parts of their schema so that other applications that depend on it can consume it. And if that would be an interesting topic for you as a webcast webinar attendee, then let me know, and let me know any other webinar topics that you would like, because my aim here is to serve you. We have a fantastic and vibrant webinar community. We see people coming to the webinars week after week, and every weekly webinar, I'm blown away at the interest. We just have phenomenal attendee list. So if there's any additional topics, please let us know. Now, here is the traditional, the industry's model for DevOps, and I don't like it. It maintains two different teams and suggests smooth handoffs between them, but we prefer untwisting this figure eight, like so. Now, this view of DevOps is more integrated and shows a single cycle of stages around the outside, from planning all the way through learning, by observing the impact of changes and how those impacts impact the people that are using the software. And in the center is the automated DevOps pipeline. It's the foundation, and it's the axle around which our cycle spins. And it's the core of our process architecture, the assembly line, the central pipeline through which all the ideas flow to be working software. But it's only the start, and it doesn't help us out much if we're struggling with a big and complex database. Now, because that scenario for web applications that we see in all the demos, that scenario is so simple. And by the way, all those public demos of the build and deployment tools that are demonstrating that and don't include the SQL Server database, they've done you a disservice. Today, you are going to see how to equip your team with a complete DevOps capability that includes your SQL Server database. So we have a complete model for DevOps-centered software engineering here at ClearMeasure, and it's enabled by the automated DevOps pipeline, and which has to include your database and every other component of your software system. There's 5 other layers that have to be accounted for, and each of those layers have to have a sound strategy, be faithfully and consistently executed, and then be measured and tuned. And we've conducted other webinars where we go much deeper into the details of this model. And if you're interested in receiving a recording of any of those, then just ask us in the chat or send me an email. If you log a question in the Q&A, we'll also be sure to get it. So let's dive into the strategy for our database DevOps. All right, so here's the first question. When it comes to deployments, the database is fundamentally different. Why is that? Well, it is different. You know, compute components don't have any state. They can be destroyed and they can be put back easily. And that's why all the simple DevOps pipelines that you find on YouTube have a website with no database, because that's the easy part. Storage components have to preserve data for years. And whether it's blob storage, table storage in Azure, a directory structure of files on disk, or any type of database, relational or document database, your deployment has to cope with data in the environment that has probably been there since before the word DevOps was coined. And if you have data before 2010, then that's definitely true, because that's when the word DevOps was first used at a conference. And when it comes to software, you know, the data is more likely to be the company asset rather than the code that operates on the data. Some of that data probably existed many years ago in a file cabinet of some sort before your company even went through a digitization age. And at some point, the current applications will be replaced by different ones, but the data will live on and will continue to grow and change. So while test environments in this situation are easier to manage because you can drop and recreate the databases, you can't do that in UAT, much less production environment. And there's a few factors that are the same and different when designing the right deployment process. And we're going to look at those. Now, as we go through here, the schema or the structure of the data is owned by the software system itself, or is owned by the versioned unit of software. So if you're doing a microservice and you have a Git repository that's just that microservice, the schema, that structure of the data should be owned by that same source control repository. And the structure should be the same in every environment you deploy to. Some of the data in the database is architecturally part of the schema and should be the same across environments. For example, if you have some standard lists that populate drop-down boxes, such as common name prefixes like Mr. and Mrs., and you know, your gender column with male and female, then these are the same in every environment. It doesn't change in production, and it's just static data. Now, some of the data is configuration and belongs to the environment itself, just like some configuration is stored in XML files or JSON files and poked in during deployment. Some of this configuration is stored as records in a database. Some systems have settings that could easily be stored in a configuration file, but they reside in a database table nonetheless. And in this case, that table in the database is environment-specific configuration. So it is going to be different in each environment. And then some of the data is administrative data. And without this administrative data, the software really doesn't do much. as an example, a customer and account records. These a lot of times are administrative data, because if you don't have any, then nobody can log in. At a minimum, if you don't have any type of login, even if it's the master admin account, nobody can log in and do anything, even create additional customer records. So some of this data is administrative data. Now, the rest of the data is what you would think of as user data, or normal data that ebbs and flows over time. Well, it rarely ebbs, it always grows. It's constantly growing, and it's constantly changing as people use the system. And so with a database in an automated DevOps environment doing deployments, you can't just drop and recreate it in every environment. You only get the privilege of doing that in environments that can recreate enough administrative data and user data on the fly in order to facilitate testing, like your private build environment and your TDD environment, an integration build environment as well. Downstream, you're dealing with production data. You got to preserve that. Absolutely important. Okay. All right. So this is another version of the same one, just kind of adding on where Octopus Deploy lives. Now, Octopus Deploy is your solution for variable management, which is going to seed the configuration data. And in some cases, you might add on some administrative data on top of that, but definitely your configuration data. If you push values into a XML file or JSON file, then Octopus Deploy does it for you. If you need to push in some of the configuration into the database, Octopus Deploy can do that as well and maintain what values need to be there across all the different environments. Okay. Now we have a an overall architectural diagram for an automated DevOps pipeline that integrates Azure pipelines, Octopus Deploy, and also some Redgate tools for database components. Because when it comes to the commercial space, Redgate is probably the top of the line when it comes to SQL Server database DevOps products like SQL Change Automation, SQL Clone, SQL Data Mask. Now there's some open source alternatives like Octopus Deploy's DB-Up open source project and Roundhouse and AliSQL that are totally free. They don't really integrate in with Visual Studio natively. They're just command line tools, but they are free and open source. But if you're looking for a commercial solution or something that's integrated with Visual Studio and SQL Management Studio, then Redgate is a really good choice there. Most of you on this webinar, just looking at job titles, are leaders, your architects or managers, a lot of senior developers as well. And you understand strategy. If you pick the wrong strategy, it doesn't matter how good you execute the wrong strategy or how much effort you put into it, you won't get the desired result. So when it comes to important technical decisions or the structure of environments, or the structure of your systems, architecture is strategy. And a pipeline, a DevOps pipeline, has to support the scenarios that you see in the box on the bottom left. We like to pack in many more capabilities, but these are the basic capabilities of any DevOps pipeline. If you don't do at least this, then you haven't even showed up for the game. And there's going to be obvious gaps. Now, notice that we don't mention anything about the database here and the capabilities, but we don't also mention anything about a web application. We don't mention Windows services. We don't mention Azure functions. We don't mention any application component type or specific infrastructure. When you're looking to create a pipeline for an application, the pipeline has to support everything that makes that application work, everything within the application box on your enterprise architecture. And I'll come back to that later, but I'm going to kind of hone in, just for simplicity, on an application that consists of a web application and a SQL Server database, so that you can see how this all fits together. And then we're going to discuss how to get that configuration up on Octopus Deploy and Azure pipelines. And your pipeline will be structured the same even if you were to add a Windows service or 2 or 3 databases. But the pipeline needs to operate on everything that makes your application go. By the way, if you would like a high resolution PDF copy of this architectural poster, then just look in the chat window or send me an email, and I'd be happy to get it for you. And this is only the top third of that poster, so make sure that you get a copy. All right, now we start in the pipeline with how to store the source in your version control system. Every part of the application needs to be in a Git repository. If your system uses microservices or any other segmentation pattern, then you'll have multiple Git repositories, each containing a single versioned and deployable unit. And I'll just call this an application. The architectural relationships are that one team can develop one or many Git repositories, but one Git repository should only hold one application along with whatever code is a part of that application. And remember, that application needs to contain the database, okay? So the source code, the schema scripts for create table and all that, that needs to be in the same Git repository. One Git repository should be built by one continuous integration build. And the integration build will produce a deployable package for each application components in that single application. So you have a deployable component, a NuGet package for the website, and a NuGet package for the SQL Server database. If you had a Windows service or a batch job or an Azure function, yep, that would be another NuGet package. And together, those deployable packages make up what you call the release candidate. And they all have names and they all have the same version number. All right, and so as you go through the actual integration build, there are some common tasks that you need to do. First of all, you need to provision the build environment, and that includes executing your database schema creation process. And the build is just a big test. You need to create the environment. And so if you have component level integration tests that call through your data layer to your database, then part of the environment setup for the integration build is to create the database from the schema scripts. So you need to execute your database migrations tool right there at the beginning of your integration build before you actually compile the code. And then do your unit testing, integration testing. Some of the test helpers will initiate data and will put in configuration data, administrative data, and then build time user data or whatever user data is necessary to run a few test cases. And then at the end of the integration build, you do your release candidate packaging. Okay. All right. Now, this is an example of the mapping from our Visual Studio solution and our logical architecture to the packaging. Notice how the SQL Server database schema gets its own NuGet package, and all of the schema scripts that represent that go in there. Your ASP.NET web application project, well, whatever is necessary for deploying that goes into its own NuGet package. Notice that how they are all the same version numbers. This is very important for Octopus Deploy. And then you also have full system acceptance tests that need their own package. Because we need to be able to deploy the right version of the full system test suite to the TDD environment in order to make sure that we're testing the right things on that TDD environment. All right, the next part of the process is our progression of environments. So let's continue. One build, it's going to have one deployment pipeline made up of no less than 3 environments. The 3 unique environment types are the TDD environment or test automation environment, a manual test environment, most common name for that is UAT, stands for user acceptance testing. And then production, shortened for prod. And you can have multiple of each type of these environments, but you need to have at least one, because these are 3 distinct types of environments. And by the way, a lot of people have multiple manual test environments. They might call them dev or QA or staging. There's so many names for manual test environments where, hey, we need to deploy the software so a person can go and check something. Those are all manual test environments, okay? But the first thing that we need to do in order to complete a continuous integration setup is have a test automation environment. Because in continuous integration, until we have deployed what was just changed, deployed the build that has a new change in it, until it deploys and starts up properly, we don't know that we just didn't totally break the system. And the premise of continuous integration is to answer the question, do I still have stable software? And it requires a deployment and a starting up of the software to be able to have a basic answer to that question. I think every person on this webinar, probably in some time in your career, has had a new build of something, deployed it to an environment, told somebody else, hey, it's ready to go. And then they go on the software and the first thing they try to do just breaks spectacularly and the system blows up in their face. That's because we destabilized the software and we were not aware of it. And so continuous integration is meant to answer that question, do we still have stable software? So do not tell your team or anybody else that you have an application up on continuous integration until you're able to answer that question, okay? And going back to 2005 when the continuous integration build book was published by Addison and Wesley, it goes through the various stages. So if you haven't read that book, I highly recommend you read that book just on continuous integration, because the word in CI, continuous integration, has kind of become part of our vocabulary. And so I do see people from time to time saying, well, we have CI set up, and then we'll kind of look at what they have, and it's an automatically triggered compilation, and that's pretty much it. That's a necessary piece of continuous integration, but continuous integration is multiple things that all together answer the question, do I still have a stable code base? And unless you're deploying it and starting up the software, you can't yet answer that question. All right. Now, when it comes to the database, let's get back to this database here. In the TDD environment, we reinitialize the whole environment, including the database. And most of the time that means dropping and recreating the SQL Server database from what is in source control. Just like in the private build script that runs on every developer workstation, even before they check in any code into a version control system, we run the private build script and it drops and recreates our local database. It proves that we still can, and it aids in a really short cycle time. In other environments downstream, like the UAT environment and production, we migrate the database schema or update it with changes. And we only run the changes that are necessary in that environment. So when it comes to the Octopus Deploy view of the different environments, in the TDD environment, we are going to drop and recreate. We're going to provision that. Now, it's important to note that the exact same database release candidate package is used for all of the environments. Once we finish an integration build and produce a release candidate, we never have to build that version again. I've heard some people say, oh, I'm going to build to UAT, or it's time to build to production. So going back to source control and recompiling and repackaging up kind of invalidates a release candidate version number. The process we're doing here is we're going to create a build that produces a versioned package that should be deployable at that time. And then we're going to use Octopus Deploy to take that exact versioned package. We're going to deploy it to the TDD environment. Full system automated acceptance tests are going to run. And if it passes, great. Now we're ready to go into a manual test environment, UAT. If there's a problem, if it fails, that release candidate version number will never see the light of day in any other environment. It's not worth it. We got a bug, we got a problem, we got something that's destabilized. But if it goes on, it's great. Now we deploy to UAT, and some people manually do some stuff. And if they find a problem, that release candidate number, never going to go further. But if it's all good, now it can go to production. So by the time we deploy something to production, that is the exact deployable package. It is the exact release candidate that has been deployed multiple times and used in multiple environments before production. We don't do anything in production for the first time, okay? All right, let's keep going. Now, when it comes to Azure pipelines to Octopus Deploy, this is important. There are two integration strategies. The first one, which I don't recommend, is the fire and forget method. And that is the release management view. Here you see on the screen with Azure pipelines. It's pretty much empty because we just use the integration build to create the release in Octopus, and then we model the rest of the deployment in Octopus Deploy. Functionally, that works, but it's got some caveats, and this is true with any build server. For your happy path, okay? There's no deployment logs in Azure pipelines, and if you use approval gates or somebody that needs to press an approve button to go to production, those approvers must have Octopus Deploy accounts as well. And if those approvers are stakeholders, as opposed to people on the development team, then that expands your Octopus Deploy user base. It's just another tool that your stakeholders have to have visibility into. Now, the other approach, which is illustrated here, is the orchestrated approach. I like the advantages here where all of the logs from your deployments to all of the environments are streamed back from Octopus Deploy into Azure pipelines, and it's all kept together. So running tests and deploying, all the logs are together. Your approvers can have stakeholder accounts and don't have to have Octopus Deploy access. Additionally, the tests can be run on a pipeline like this. That can be run in your TDD environment in Azure pipelines after Octopus Deploy finishes a deployment. If you fire and forget and create a release and push it over to Octopus Deploy, you have no capability to run post-deploy test suites. And that's a problem because every step of the way in a pipeline needs to have a quality control measure, and test suites are a big hammer in our tool belt when it comes to that. Definitely in the TDD environment, you want to have fully deployed tests. And so you need to be able to run an in-unit or X-unit test suite in your TDD environment after the deployment happens. Now, here's a caveat. Some advanced Octopus Deploy scenarios don't have a parallel in Azure pipelines. For example, Octopus Deploy tenants and channels don't really have a representation in pipelines. The normal day-to-day cases work perfectly fine, perfectly well. But if you're dynamically provisioning and configuring environments and creating parallel environments like multiple UAT environments dynamically, or creating environments by branch, then you'll have some deployments that happen in Octopus Deploy without tracking in pipelines, just because Octopus has more sophistication in those areas than pipelines does. All right, this is what your pipelines configuration is going to look like. You're going to use the step template in your TDD environment configuration to create the Octopus release. Then Octopus Deploy is going to deploy to the first environment in your lifecycle, which is TDD. And after that is going to return control here. Then we're going to download the package for our test suite, for our full system acceptance test suite. We're going to poke in, connection string and where the web application URL is, whatever configuration we need to use. And then we're going to run the in-unit test suite with VS Test, and the test results will be captured. For subsequent deployments, you need to make a choice between the deploy and the promote task. Now, promote uses logic baked into the Octopus Deploy lifecycle configuration. It'll deploy to the version currently in the previous environment. So you're saying Octopus Deploy, guess which version that I'm thinking of. I prefer the deploy task. It's more explicit, and it allows us to specify in Azure pipelines or in the build server, specify exactly what version to deploy. And so it doesn't leave any wiggle room. Now, strategically, you got to decide which system is going to, quote, own the responsibility for deciding what version to deploy to an environment. And I prefer the explicit method. Now, if you're going to pass through some variables into Octopus Deploy, then you need to make sure to check the box prompt for variable. This allows you to pass through variables from your build server to Octopus Deploy. And I didn't highlight that on the previous slide, but you can pass them in command line, any number of variables. And a lot of times you'll want to include build server level variables and just pass them on through to the deployment. And that's your mechanism for doing it. If you forget to check the box, doesn't matter that you're passing it in command line, Octopus Deploy is not even going to look to see if it's there. This is what your Octopus deployment process is going to look like. It's always good for us to tell application insights that we're deploying. But then first thing, we're going to do a package deployment. We're going to grab that database package, and then there's going to be a PowerShell script, I'll show you that later, that actually runs our database migration tool. And it's just one package step. Then next, we're going to take our web application. So yes, literally, the Octopus deployment process is this short when it's done properly. If you have PowerShell script step, PowerShell script step, PowerShell script step, and you have to scroll and it's a whole bunch, it's like its own procedural program, it's gotten out of control. Now we've seen that before, we've seen that a lot, but this right here on the screen is what it should look like. You should have one deployment step per deployable component in your application. Yeah, if your application has 4 Windows services that all have to be deployed, all the code for those Windows services are stored in the same Git repository, or if they're deployed as Azure functions or however they're deployed, then you're going to have 4 additional steps here, but one step per. Okay. Now, this is what the release candidate packages look like. And if you were to open the database package, then you would see something akin to the right. We have a PowerShell file that's, update. This kind of has the word Azure in it because we're using Azure SQL in this example. And the script folder is going to have all the SQL scripts that, when run in order, give you the right version of the schema. The first SQL files are going to have things like create such and such table. And then maybe the last one is going to be, update or alter table and add a new column, things like that. Okay. Now, if we dive into our PowerShell script that is going to be executed by Octopus Deploy that is in our database package, then we are going to see that we're calling our database migration tool. Here it happens to be aliasql, but we're passing in variables for are we rebuilding, or the database action is either rebuild or update. In the TDD environment, we're rebuilding. It's going to drop and recreate, but in the rest of it, we're just going to update. What's the database server, the database name, username and password? All of those come from the caller. And so what we do in a script like this is we grab the environment variables and we use them. And this type of script can be run in the integration build or anywhere, because the variables are going to be available there. So it's reusable. Now, a variable is a piece of data. You have to decide who owns it. Is the system of record the build system or the deploy system? Or is it some external system where data just needs to be pulled in, like Azure Key Vault or wherever else? You want to think about the DRY principle. Don't repeat yourself. If you don't create a strategy for configuration management of these variable values, then you're just rolling the dice on a management nightmare that's going to happen really soon. Every system has configuration management needs, and you must design it. Remember, design doesn't just happen. It has to be intentional. We've seen variable screens both in Octopus Deploy and in Azure pipelines where you just scroll for days and you can see there's duplicates or duplicate values. And you know what? It doesn't even mean, they may be unique keys, but if the values are duplicates, you need to normalize that. So I want to give you an example. We have database name, database password, server, user, but then we also have connection string. Well, we are dynamically building the value of the connection string by using the other variables. This is what I mean by don't repeat yourself. Don't have duplicated values, even if you have to have a lot of variables. Make sure to structure them properly. Now, if I jump back into the database step in our Octopus Deploy process, you will see that we are grabbing the particular package, onion DevOps architecture.database, from our feed. And in this case, we are using our Azure Pipelines feed or Azure Artifacts rather than the NuGet feed because we are running automated tests. We could easily pull them from the Octopus Deploy NuGet feed, but the Octopus Deploy NuGet feed is not a full NuGet server. It doesn't allow external clients. So we just put all of it in Azure Artifacts, and Octopus Deploy grabs it from there, because then we can also pull the package for the full system tests. Whereas if we pushed everything to Octopus Deploy, there's no way for the build server or pipelines to reach back over and say, give me the correct version of the full system acceptance test package. Okay. Then we're the custom deployment script, we have that configured to run that PowerShell file. And this is a little snippet that we use that really is calling the PowerShell file that is inside our package. And in this case, we've elected not to use the postdeploy.ps1 file or a deploy.ps1 file, just so that we could translate the variables into the lowest common denominator and make every script that we store equally usable on a private build, an integration build, and the deployment. So if you create a deploy.ps1 or a post-deploy.ps1, works great, works phenomenally well, but it's going to be a one-off script that's not going to be able to be run in your private build or your integration build, because it's going to be grabbing Octopus Deploy variables from wherever they need to be pulled from. Now, by having just a regular PowerShell script, we can take the context of this running an Octopus Deploy, and we can set environment variables, and then the script just has a dependency on regular environment variables as opposed to Octopus Deploy variables, and it works great. All right, now, as we go along, let's talk about parallel workflow of our teams. Here's the portion of the process for branches. And we can enable any number of developers to make changes in parallel on branches because of two enablers. First, we branch from master, and we have our build and our first deployed environment active on all branches. And it's important that we have a database migration approach that is resilient to branching, and not only allows every developer to have their own local SQL Server database that they can only experiment on a branch, but also have the integration build equipped so that it can run parallel on multiple branches. Most of the time, you want that. Now, the developer on the branch can push changes onto that branch, can commit it, can push it to source control, and then benefit from the full series of test suites that are in the pipeline, including a complete deployment. Only changes that are merged back to master are actually eligible to continue to be production level release candidates. And of course, you want your feature branches to be short-lived, but you want an integration build to run on your feature branch. Create a kind of beta or alpha level release candidate package so that it can be deployed to the TDD environment. You want to multiplex your TDD environment so that you can have multiple instances of the application side by side, or use cloud PaaS provisioning. Now, if you run on virtual machines, a really easy technique is to tokenize or push the build number into the website name, or push the build number into the database name. And then you're creating, uniquely named websites and uniquely named database names. And, you can kind of share a single database server or a single IIS server if you're on VMs. Now, if you're in the cloud with PaaS, you just create another instance of app service, you kind of use it, another instance of Azure SQL, and then you delete it and you're off to the races. It's easy. So there's a lot of information. I understand that. We had some questions come through, and I think I was able to answer those in line. If there's any questions that come through now, I'll make sure to answer those. We've seen integrating the database into an automated build and deployment make a huge impact for our clients, and we have some stories on our website. When equipped with a complete and professional work environment that includes having your database deployments integrated with your Octopus Deploy process, we see teams truly becoming world-class. We hear of teams who move fast at Google and Netflix and Microsoft, but any of your teams can be just as effective when equipped properly. We've seen it happen. So, one easy way to get some help is to have us do some architect level advisement or consulting, or just a second pair of eyes. You saw our free 30-point DevOps inspection offer. If you've implemented Octopus Deploy and you would like a free review to get hey, reach out. We'd be happy to do that for you. We are a software architecture company that just loves seeing your development team be self-sufficient and move fast, deliver quality. You want to do more in-house. You don't like having to outsource development, and we don't like that either. So we want to make it so that your team is equipped to do more in-house, and that brings us joy. So a lot of people are taking advantage of our offer. I love having a packed schedule with this, and so just contact us for that. Also, my direct phone number and email address and Twitter are right here as well. And I think we've answered all the questions. I know this is a lot of information. So thank you all so much for joining the webinar, and stay safe out there, stay healthy, and have a great day. Keep shipping.